Kia ora koutou, Reese from QuickSense here, and today we're looking at gradient of a curve at a point. This question gives us both an equation and a graph. Right? It's wanting us to determine the gradient of the curve where x equals 4. So let's just mark that point on our graph. Right, it's going to be here. And the gradient is the line which meets the curve at a tangent. Right, so all that means is that if I were to draw a straight line, it hits the point of the curve. Let's see if I can be a bit more precise about this. It hits the curve at the point we're interested in, and it does so at a right angle. So as we can see here, the gradient is going to be positive. So I know that going into my answer, if it's negative, I've done something wrong. So how do I do this? Well, I have to differentiate the function or the equation of the curve. So let's differentiate y with respect to x. Okay, so what does that equal? Well, what I want to do initially is I actually want to change this equation. So I'm going to expand the brackets, right? So that's going to give me, let's keep this simple. So that's x squared minus 3x minus 3x, well that's minus 6x, plus 9 minus 4. That simplifies to x squared minus 6x plus 5. Okay, so now let's differentiate this. Right, the 2 comes down and becomes 1 at the top. The second expression, the second term becomes that. Okay, now this is my gradient, or this expression tells me something about the gradient. So I can substitute in x equals 4. So what's the gradient when x is equal to 4? 2 times 4 is 8 minus 6. The gradient is equal to 2, which is positive. And actually, from our graph, right, we can see that it looks about right. In this next question, we're going to be tackling something known as kinematics, and that's essentially the study of speed, acceleration, and position in space. So first of all, to find the acceleration, right, well, this tells me where is the object given some time, but I can differentiate this. So if I differentiate h with respect to t, right, I get negative 3t squared. And this tells me the velocity. How fast is it going at a particular time? But I can also determine, right, the next step up is how quickly is my velocity changing. Right, so that's my acceleration, which is actually what this question is asking about. So the way I write this, right, is I'm going to differentiate this again with respect to t, becoming minus 6t. And this is acceleration. Okay. Unfortunately, this question's giving us a position in space, a height. Right? So I have to determine, well, what is the height, or what is the time, right? What is the time? Let's use this pink here at that period. So we're going to actually substitute in height equal to 23. 23 equal 50 subtract t cubed. We do a little bit of rearranging. T cubed is equal to 50 minus 23 equal to 27. T is equal to the cube root of 27, which is 3. So now I'm going to substitute in 3 to this equation. Right? And what do I get? Well, that is equal to, so this is my, let's just put acceleration over here, equal to negative 18 meters per second squared. which makes sense because it's falling, right? So it is accelerating downwards.